In this video, we're going to be going over how to find the equation of tangent lines at a given point on a parametric curve. So here I have a problem where I'm given the x and y curve equations for the parametric function, and I am told to find the equation of the tangent line at each given point on the curve. And these are going to be my 3 points. That's number 1, number 2, and number 3. So, what's going to be helpful first is before you even begin evaluating at each various point, find the derivative. And so that's going to be dy over dx. So the way to do this, this is the same thing as saying the derivative of the y function over the derivative of the x function. And if we simplify that, what we're going to get is you're going to have 2 sine squared theta. The derivative of that is going to be the derivative of 2 sine squared. We're taking the derivative of that. I'm going to write it like that because it makes it easier. And then the derivative of 2 cotangent theta. So this is going to be power rule. You're going to have 2 times 2 sine theta, 2 minus 1 is 1, times the derivative of sine, which is cosine. All of that divided by the derivative of cotangent is negative cosecant squared, so you're going to have negative 2 cosecant squared theta. That simplifies to 4 sine theta cosine theta all over 2 cosecant squared theta, and that simplifies to negative 2 sine squared theta cosine theta. So that is your derivative function. And now what you're going to do is, now that you have this essentially this is going to be your slope. So when we write our equations, this is going to be where you're going to plug it into theta over there, and then that's going to be your function. So the way to find the theta value now is, it's going to be helpful if we make a little table. So I'm going to have the x, the y, the theta value. I have negative 2 over root, negative 2 over root 3 halves. So the theta value, we're given this equation, and essentially you're just going to plug that in. So first, you have negative 2 over root 3 equals 2 cotangent theta. Let's divide both sides by 2. You have negative 1 over root 3 equals cotangent theta. If you think back to your unit circle, this value is going to be right there. That's your 2 pi over 3. So theta is 2 pi over 3. Do the same thing for 0, 2. You can also use the y function. Actually, let me just do that here. You're going to have, if you do the y function, when you say 3 over 2 equals 2 sine squared theta, divided by side by 2, 3 equals sine squared theta. So root 3 equals, or plus minus root 3 equals sine theta. That essentially it's we're gonna look only at the positive points, because when you plug it in, if you get negative pi over 4 pi over 3 over here, when you plug that back in, you're going to notice it doesn't work with this function. So we're going to keep it limited to the positive value so that it also works for our x value, and that's going to be positive. That could be anywhere here or here. And the reason I avoided using sine squared theta here is because of that squared, because it increases the number of solutions you have, and then you'd have to check it back in. But you get the same answer, because you're going to plug in each of these values back into this cotangent theta, and you're going to get the answer. So that'll still work. So going back to this, actually let me just erase this. So going back here, you're going to have 0 equals 2 cotangent theta equals 0, and that is going to be at the pi over 2 value. So this is your pi over 2. And then you have 2 root 3, 1/2. Plug that in back here. You're going to get 2 over root 3 equals 2 cotangent theta, divided by 2 on both sides. Root 3 equals cotangent theta, and that is your pi over 6 value. That's going to be pi over 6. And just to be clear, you could also say like 7 pi over 6, etc., etc. We're going to you're going to get the same answer if you were to use 7 pi over 6, because essentially what we're going to do with these values is now plug it back into this slope equation. So now I'm going to have a separate place for the slope. I'm going to erase all this. And now I'm going to plug back in our theta values into the slope formula that we derived earlier. So if you say first, -2 sine cubed of 2 pi over 3 times cosine of 2 pi over 3. Now sine 2 pi over 3 is root 3 over 2. So that's going to be root 3 over 2 cubed, and cosine 2 pi over 3 is 1/2. This gets canceled. You're going to have 3 root 3, negative over 8. So that's your slope. For number 2, you have -2 sine cubed of pi over 2 times cosine pi over 2. We don't need to evaluate this completely because we know that cosine pi over 2 is just 0, so that's 0. And then if you have number 3, you're going to have -2 sine cubed of pi over 6 times cosine pi over 6. That's equal to sine of pi over 6 is 1/2. -2 1/2 cubed. Cosine pi over 6 is whoops. That was pretty bad. Root 3 over 2. That is equal to negative root 3 over 8. You have negative root 3 over 8. So now we have everything we need to basically write our equations. I'm going to go back and erase all of this so that we can now write our equations. I'm going to first write them in point slope form, and then you can change it to slope intercept form, however else you want it after that. It's just basic algebra. So you have y minus 3 over 2 equals your slope, x plus 2 over root 3. Next you have y minus 2 equals, your slope is just 0, your x is just 0. So here you just have y equals 2. That's your number 1, that's number 1, 2, and number 3, y minus 1/2 equals negative root 3 over 8. I'm just realizing how bad that is. That's an 8. Root 3 over 8, x minus 2 root 3. So these are your equations now, and if you were to graph this in Desmos, what you would find is that at each of these points, you should plug this point in, plug this parametric curve in, and plug this equation in, this line in, and you're going to see that it's going to be tangent to that curve. So we're going to do one more example where you are not given, we were given these points here. Now we're going to look at an example where we're not given the point. Let's say x equals to 6t, y equals to t squared plus 4, and we're evaluating at t equals 1. So now here, same idea. You're going to first find dy over dx. Now dy is 2t, and dx is 6. That's t over 3. That is our, that's our slope. Now, this is going to be your key to basically figuring out what your value is. So now we can plug this in here. We're going to plug this back in here. So what we're saying here is that find the slope, which we have the formula for. At any given point on this curve, the slope will be t over 3. At the point t equals 1, the slope will be 1/3. Okay, now what we have is we're going to plug this back into our x and y values. You're going to have x equals 6, 1, 6, and y equals 1 squared plus 4. That's 5. Your equation then becomes y minus 5 equals 1/3 x minus 6. If you wanted to simplify that out, that'd be 1/3 x minus 2 plus 5. Y equals 1/3 x plus 3. So the way to solve for tangent lines on a parametric curve is to first find, this should be your first step. Then if you're given the points, evaluate them at each point and find the theta value, and then find the slope. And then you can come back here and that's your equation. Or first find the slope, plug it in for your slope value at the given parametric point, and then plug into your x, y, and then get your answer. So I hope this video was helpful, and good luck on your test. In this video, we're going to be going over how to find the equation of tangent lines over. So I hope this video was helpful.